All right, here's going to be our homework help video for the homework function operations and inverses. Go through a wide variety of these ones, starting with just how to evaluate a function. So number one says that h of x equals 3x minus 4. We say that h of x. And now it's telling us to find h of 9. So this means between our initial definition here and what we've been told to find, the x has been replaced with a 9. So if the 9 replaces the x here, then it also has to replace the x here. Another way to think of that is that this is a machine that's supposed to take some sort of input x, multiply it by 3, and then subtract 4. Well, we've been told the input is now 9, so we're going to multiply that by 3 and subtract 4 and see what we get. That's off to a bad start here. 27 minus 4, 23. There we go. If we evaluate at 1 over here, 1 cubed plus 3, 1 plus 3 is 4. All right. Perform the indicated operation. Here we are adding together the two expressions. So I'm going to write the expression for f of x, negative 3 plus 2, the expression for g of x, x cubed plus 3x squared, and I'm going to look to see if there's anything that can be combined. This can't be combined in any way, so I'm just going to put it into standard form, where I write it in descending exponents and call it good there. So that's our final answer there. Here we're subtracting the 2, so 4a plus 2 minus, then I'm going to put this in parentheses, a minus 4, because that is the expression that represents h of a. This is going to become 4a plus 2 minus a plus 4, which is equal to 3a plus 6. Our final answer there. Number 5, we got to multiply the 2, so I'll write out h of x as an expression, 4x minus 1. Multiply it by g of x. And if you need an intermediate step to be able to get to here, take this form here and write it down as h of x times g of x, like that, and then replace h of x with its expression, g of x with its expression. All right, let's FOIL this. We're going to get negative 8 x to the third. Outside we get 16 x. Inside we get 2x cubed, or no, just 2x squared. And last we get a minus 4. Get that into standard form. Negative 8x cubed plus 2x squared plus 16x minus 4. Standard form. Done with this one right here. Number 6, now we're dividing the two functions. It's h over g. Here, I'll write out the intermediate step. We've got h of x over g of x. Those expressions are x cubed plus 4x squared all over 4x minus 2. We look for a way to simplify this. If I can find this exact factor in the top, I can pull it out. But there's no way to really simplify this, so this is our final answer here. Give me 1 second here. Send a text message. System's good, but it will not let me pause. All right. So now we get into our compositions of functions. In 7, we've got h of g of n. This means we are doing, if I could write this down a different way, h composed of g of n, or h parentheses, g parentheses n. These are all equivalent. What this means is that I want to evaluate h, this function, at the value of g of n. So I need to replace the n's right here and here with what I'm evaluating at, and what I'm evaluating at is g of n. So n squared plus 4n becomes g of n squared plus 4 times g of n. And now I can replace the g of n's with their expression, which is n minus 5. So this becomes n minus 5 squared plus 4 times n minus 5. So the expression here has replaced the variable in this expression here. We always have to do it the right way. It's very different if we replace the opposite direction. Let's simplify this. We're going to get n squared minus 10n plus 25 plus 4n minus 20. Combine like terms, and we'll get n squared minus 6n plus 5 is our final answer. All right, let's take a look at number 9. We're doing f of g of negative 2t. So what this means is do f of g of negative 2t. All right, so let's figure out what g of negative 2t is first. So that's going to be equal to this expression, except for I'm going to replace the variable with negative 2t. So negative 2t squared plus 2 equals, if I distribute that exponent, 4t squared plus 2. So this is the expression for g of negative 2t. This is going to go right into f of x. So I can say I'm doing f of 4t squared plus 2, which now equals 4 times 4t squared plus 2 plus 5. Distribute that 4, we get 16t squared plus 8 plus 5, 16t squared plus 13. Let's double check I didn't make a mistake on that one. 16t squared plus 13. All right. Number 10, this one would be a little bit too hard for the test. This is called a linear combination, but I think that many of you out there could get this one even without my help. Let's try it now. We got 3g minus 2f of 4x. So what we want to do is figure out what 3g of n is, and that is just this expression here times 3. We are tripling it. All right, this makes a lot of sense. But that's what 3g would mean. And so that's 6n plus 15. Likewise, negative 2f of n is we're going to take this expression here and multiply everything by negative 2. And we're going to get negative 2n cubed minus 4n minus 6. All right, now I'm going to combine those two. I already put the negative in here, so I can just add these two together. And so now I've got 6n plus 15 minus 2n cubed minus 4n minus 6. We'll get that into standard form. And what do we got? Plus 9. And now I'm going to replace the n's with 4x's. So this becomes negative 2 4x cubed plus 2 times 4x plus 9. This here becomes -2 times 4 to the third is 64, right? Double check that. 16 times 4, 64. X cubed plus 8x plus 9 for a final answer of -128 x cubed plus 8x plus 9. And let's check that one too. Yep. All right. State if the given functions are inverses, use composition functions to verify. So what this means is that if I do f of g of x and these two are inverses, then I should get x if they are inverses, because they should undo one another and I should get the input as my output. X was the input, x should be the output. So let me do f of g of x. So that's -5. I replace this x here with this whole expression, -15 minus 7x all over 5 minus 15 all divided by 5. And let's simplify. Let's see if we get x. This 5 here cancels with this 5 here, leaving the negative behind. And once I distribute that negative, I'm going to get 15 plus 7x minus 15, all divided by, whoops, this was supposed to be a 7 on the bottom. So it's good. F is my outside operation. All right, the 15 and the -15 cancel out, and I'm left with 7x over 7. The 7 and the 7 cancel out, and I'm left with just x. So the answer is yes, inverses. Okay, find the inverse of each function. Very easy setup to inverse problems, and then it's a little bit harder in the follow through. What I need to do is first replace the h of x with a y. So y equals the cubed root of x plus 1 minus 1. Then I need to swap my variables. So these swap. And I get x equals the cubed root y plus 1 minus 1 here. Now I just got to isolate y, add 1 to both sides. We get x plus 1 equals the cubed root of y plus 1. Let's cube both sides. And we're going to get x plus 1 cubed equals y plus 1. Let's simplify x plus 1 cubed. X plus 1 cubed is the same as x plus 1 times x plus 1 times x plus 1, which gets us x squared plus 2x plus 1 times x plus 1. Distribute again. We get, just going to multiply this to both these, middle to both these, last to both of these. That way I'll be sure to multiply all of them. X cubed plus x squared plus 2x squared plus 2x plus x plus 1, or x cubed plus 3x squared plus 3x plus 1. Binomial theorem appearing there. So now I've got x cubed plus 3x squared plus 3x plus 1 equals y plus 1. I want to subtract 1 from both sides. those cancel. And when I go to write my final answer, I need to put it back in a function notation. So it started with h of x. The inverse of h of x is h to the negative 1 of x. Then I'll write out my function again. X cubed plus 3x squared plus 3x. So that's 13. Let's see if we got it right. Oh, they did. Okay. So in the answer key, they didn't expand x plus 1 to the third. So either's fine. That would have saved us some time, though. The inverse of 15 looks really simple. Y equals x minus 4. This becomes then x equals y minus 4. Add 4, add 4. Y equals x plus 4. Or g to the negative 1 of x equals x plus 4. Just give me 1 second here. Hello? Callie, can I call you back? In like 5 minutes or? Yeah? Okay, bye. All right. Find the inverse of each function, then graph the function and its inverse. I'll just do one of these. We'll call it good. 17 looks like a little bit more tricky, so we'll do that one. When I find the inverse, I'm going to switch x and y. So this is going to become x equals negative 3/5 times y minus 6/5. Add 6/5 to both sides. We'll get x plus 6/5 equals negative 3/5 y multiplied by the reciprocal, 5 over negative 3. And we get negative 5/3 x minus, let's see, that'd be 30 over, or we could just cancel the 5s. Minus 2 equals y, so there's the inverse. And now let's plot both of these. So starting at negative 6/5, and then going down 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Connect those up with a line. Okay, and we've got our original, or our inverse. We're starting at negative 2, goes down 5. Oh, we can't go down 5. Let's try going up 5, backwards 3. Connect those with the line. All right, and this is very characteristic of an inverse function graph. We're going to learn this tomorrow, but they always intersect on a 45-degree angle line. So they're always like symmetrical over this line. It looks like they're reflecting over it. That is just a property of inverses we're going to talk about tomorrow. All right. Hopefully this was a good start on the homework, and I will talk to you